students, myself Aperture welcome you all again in the session of antenna and wave propagation subject. In this video we are going to learn about some parameters or the antenna terminology. Let's see in second part what we will learn. First, that is the radiation intensity, half power beam width, polarization, antenna efficiency, front to back ratio, and at last effective aperture. So let's enlighten it one by one to get more about antenna specification. First, that is the radiation intensity. The term intensity means quantity which is used to measure brightness or the field. Suppose we have any light source in on condition, then the light intensity is more at the near of the light source and it is become less at the far distance from it. So same way we can also measure the electric and magnetic field of the antenna. The standard definition of the radiation intensity is the power radiated from an antenna per unit solid angle is called the radiation intensity. The radiation intensity is a far field parameter which can be obtained by simply multiplying radiation power density by the square distance. Pointing vector or power density is depend on the distance from the antenna, while radiation intensity is independent of the distance. So this is about the radiation intensity. Now half power beam width. So as name said, it is half power of the beam width. The antenna beam width is a measure of directivity of an antenna. Beam width is aperture angle from where most of the power is radiated. According to the standard definition, the angular separation in which the magnitude of the radiation pattern decreases by 50% or minus 3 dB from the peak of main lobe or main beam is the half power beam width. Here we have the figure showing the half power beam width. So it is the half power beam width where the antenna power is 50%, or you can say minus 3 dB, the peak of the main lobe. When a line is drawn between radiation pattern, the origin and the half power point on the major lobe, on the both sides, the angle between those two vectors is termed as half power beam width. Now before we going to explain next terminology, there is a quiz at the end of this session. You must attempt the quiz so you can check what you learn from it. Now, polarization. An electromagnetic wave and the electric field of this wave oscillates particular to the direction of propagation. It refers time varying behaviors of the electric field strength vector at some fixed point. It also refers the direction of electric vector in the relation to the direction of propagation. Polarization is the orientation of electric field vector of the magnetic field wave produced by the antenna. For most of antennas, the orientation of the antenna conductor determines polarization. Polarization may be vertical, horizontal, or elliptical. Depending on how the electric field is oriented, we classify polarized light into three types. First, that is linear polarization, circular polarization, and elliptical polarization. So here we have three types of polarization as we listed. Now next is the antenna efficiency. Now in first part of terminology we had discussed about beam efficiency. So on basis of that we can also define or measure the antenna efficiency. So let's see what is. The antenna efficiency is defined as the ratio of power radiated to the total power supplied to the antenna, and it is denoted by the eta. This is the symbol of the antenna efficiency. A high efficiency antenna has most of power present at the antenna input radiated away. A low efficiency antenna has most of the power absorbed as losses within the antenna or reflected away due to the impedance mismatch. So this is all about the antenna efficiency. Now, what is the FBR? That is front to back ratio. It is defined as, the name said, the ratio of power radiated in forward direction to the power radiated in the backward direction. We can also derive the formula from it, that is front to back ratio is equal to power radiated in the desired direction to the power radiated in the opposite direction. So here we have a figure which is showing the main lobe and side lobes. So this is the total power radiated in the front side, and the back lobe, that is the total power radiated in the opposite side. So we can ratio of these two power, we can get the front to back ratio. Now the last, that is the effective aperture, that means the area. An effective aperture is defined as the ratio of the power delivered to the load at the incident power density. The aperture of an antenna is the area through which the power is radiated or received. The concept of aperture is most simply induced by considering a receiving antenna. Effective aperture describes the effectiveness of an antenna in receiving mode. Here in the figure we have see that the antenna transmitting EM field having an aperture at particular distance, and this is the distance where we have to place the receiving antenna for better reception. This area is called reception area. An antenna with larger aperture has more gain than one with smaller aperture, since it is capture more energy from the passing radio wave and can radiate more in that direction while transmitting. Now let's see what is the assignment for you. First, explain HPW, that is half power bandwidth of an antenna. What is the antenna efficiency? Third, that is explain FBR, that is front to back ratio of an antenna. Describe the effective aperture of the antenna. Or you can attempt the quiz based on this video by the link given in the description, or you can scan the QR code. So total 10 questions with 50% passing marks. So this is the end of the part 2 session of the antenna terminology of the subject antenna and wave propagation. That's all from me. So see you students in the next session of antenna and wave propagation of LJP EC-ELE. Thank you.
If you like this video, please subscribe and like our YouTube channel LJP EC-ELE, and don't forget to click on the bell icon to get latest video update fast.